Right, so, good morning everybody. So I apologise that we're starting late. This is due to Dr. Bennett being late, so I'll moan to him later. It's not our fault. But thanks all for getting here on time. So, let me just catch my breath. So, welcome to Lecture 2 of MATLAB. I can't talk over you guys. I'm sorry. Right. So this is called complex numbers and 1D arrays. So what are you doing in maths at the moment? Sorry? So what are you doing in maths? Matrices. Have you done complex numbers yet? Yeah, okay. Well, I like to teach MATLAB in a way that basically makes your life easy, okay? So, in the sort of the vein that anything, who's your maths tutor? Dr. Chu. Does he teach you maths? Dr. Who? Okay, well anything he can do, I can do better, right? So, I'm going to teach you how to do complex numbers, but in a really easy way that will make your life so much easier, especially for your maths coursework, okay? So that's the first thing we're going to cover. We're going to do that super quick today. And then we're going to get on to 1D arrays. So here's an outline of today's lecture. Recap of last lecture, complex numbers in MATLAB, processing very, very big amounts of data. So this is called basically arrays, and it's quite an important topic. And it's very important to grasp this topic because it's going to get spread throughout the whole course. It's not that difficult either. We're going to look at arrays, plotting graphs, making music, and extracting subarrays from big arrays and building arrays. Okay. So last week I tried to convince you that basically today you cannot be an engineer without knowing how to program a computer. It just doesn't work. You cannot be a modern engineer without programming a computer. That era stopped in about 1960. And I tried to I gave you some examples. This rocket, for example, only basically being held up on its thrust by a computer. And we learnt that remembering commands in a computer, remembering MATLAB commands is basically easy. The real difficulty you guys are going to have is taking that real-world problem and breaking it down into little subtasks that you can easily program into a computer. And we did some various examples, and we did sort of flow diagrams of making a cup of tea. And if you remember the joke I told you about the computer programmer who was told to go to the shop and get some milk by his wife, but he came back with 6 eggs, or lots of eggs. It was because he followed the instructions of his wife exactly. And I tried to sort of emphasize to you that... guys? Thanks. So I just can't talk over people. It just makes my life super difficult. So, yeah, thank you. So computers follow instructions exactly. Whatever you tell them to do, they will follow them. And you'll run into this again and again and again, and it actually kills people. We'll look at some examples later of computers following instructions to kill people in terms of aeroplanes, things like that. Right, so last lecture I taught you about this scientific notation with the E. And I said in a computer, if you want to write 1.6 times 10 to the minus 19, you can do this very easily by going 1.6 e to the minus 19. This has nothing to do with exponential. It actually stands for exponent, which means like to the power of. We also looked at built-in function. You had a good play at these in the lab. And I know you all finished the lab pretty early this last week, but that's because I hadn't had a chance to teach you much material. And we looked at things like sine and cos and built-in constants like pi. And you should have had a little play with pi in the lab. Then I taught you how to do basic maths in MATLAB. So multiply, divide, subtract, raise to the power. All pretty easy stuff if you ever had a go at Excel before. So this shouldn't really be too new for you. Then we started learning about variables, and I basically said a variable is like sort of a variable in maths. And if, for example, you had the equation y equals 2a plus 3b plus 7c all to the power of 2, and you wanted to know what y was for a equals 1, b equals 4, c equals 8, in MATLAB you could evaluate this expression very, very easily by just typing a equals 1, b equals 4, c equals 8, and then y equals 2 times a plus 3 star b plus 7 star bracket c to the power of 2, and you've all played with that in the lab and sort of got used to using those commands. And very importantly, I said, when you think of a variable, you can think of a variable like basically a box with a big letter on the side of it. So this box here is called A. This is the variable A. And this box holds the number 1. You can sort of think of this in your head. And you can think of the box variable b being a box with b written on the side that holds number 4, and the box c being a variable that holds number 8. And the result y is also a variable, and it stores the result, which is 462. Very good. Easy stuff. Now, complex numbers. I'm going to teach you everything you need to know about complex numbers in the next 4 minutes, okay? And it's going to be super efficient, and it's going to make your maths life super easy. So, now, so Dr. Chu tells me you've been doing complex numbers. Just take a seat there, guys. I think we've done that. So, in maths, they've taught you that if you want to write a complex number, you write A equals 34 plus 42i. That's a complex number. Or B, for example, can be 7 plus I, or C equals 3 plus 3i. These are just complex numbers. Easy, right? In MATLAB, guys, I can't talk over you. Thanks. So something about me. If I focus on other people's voices, so I'll be listening to your conversation rather than thinking about the lecture. And if I go for coffee with anybody or something, I'll always be listening to the next table. So I get super distracted by this stuff. That's why I jump on it. So sorry, I'm slightly more touchy than other lecturers. So in MATLAB, if you want to define a complex number, it's super easy. All you do is just write it the same. No difference, exactly the same. So if you want to define number A, just go 34 plus 42i. So all you've got to remember to do complex numbers in MATLAB is just remember that I. Just put an I. But you know that already. So you can now do complex numbers in MATLAB. Now, Dr. Chu, or whoever you've got, has been teaching you stuff like this. Does this look familiar? Yeah? A bit complicated. So imagine you wanted to multiply numbers 34 plus 42i and 7 plus i. This is how you'd go about doing it. You'd go 34 times 7. Write that there. 34 times I. Write that there. 42i times 7, 42i times 7, 42i times I, 42i times I. Then you basically multiply that together, whatever number that might be, multiply that together, multiply that together. Do you remember that I times I is what? Minus 1. Then you've got minus 42. And after a lot of work, it's taken me about 2 minutes to explain this to you, you get the answer, which is that, apparently. However, this is a lot of work, and we don't like work in MATLAB. So, this is how you do it in MATLAB. Much easier. All you do is you just bang in brackets, 34 plus 42i, star, because we're multiplying, 7 plus I, hit enter. It does it for you. So now you can multiply any complex numbers together completely, consistently, and you'll always get it right. Now, because this is a computer, we can make it much more complicated, but it doesn't get more difficult for us. So we can go 3 plus 4i, star, 7 plus I, star, 3 plus 4i, and just go on forever. It's not a problem for the computer. As long as you can type it in, you can now evaluate it, and it'll get it 100% correct. And this, apparently, is the answer. So now, there's no excuse for you to not get 100% in the complex numbers part of your coursework. Now, what I recommend you do with this is just use it to check your maths. Just do it by hand, but then use this to check. So you should all get good marks for complex numbers now. And of course, variables also work with complex numbers. So we can define the variable 7 plus I as A, or the variable b is 8 plus 8i, or variable c is 1 plus I. And also, all of the operations we learned before work with complex numbers. So adding, subtracting, raising to the power, dividing. And we can write little scripts to do work on complex numbers. Now, this might take you a minute to type in by computer, and get the answer, it might take you 10 minutes to do by hand. So you've already got a super time-saving engineering device. Okay? So that's one use for MATLAB. So, I've taught you complex numbers. Any questions? No? Good? Right. Was there a question? No? Good. Right. So I sometimes do that. I try and catch up with the maths syllabus in a very, very quick way, just to make your life a bit easier. So now we're going on to the real topic of this lecture, which is basically processing very, very big amounts of data. And very often in engineering, you have to process gigabytes or megabytes of data, and this will teach you all about how to do that. So, imagine, so I'm going to pick on you guys there, because you were talking earlier. Sorry. Imagine I wanted to calculate the mark of this student, this student, this student. What I could do is I could store in MATLAB their marks in variables. So I could define mark 1 as 72, mark 2 as 40, and mark 3 as 50. And then if I want to calculate the average mark, I'll just go y equals mark 1 plus mark 2 plus mark 3 over 3. And if I did that in MATLAB, very simply I'll just go mark 1 equals 72, mark 2 equals 40, mark 3 equals 50, then type in y equals open brackets mark 1 plus mark 2 plus mark 3 over 3. And sort of pictorially, in my like variables as boxes analogy, you could look at it like this. So you've got like one box, just look at the time, how are we doing? Quite late. Okay, so we've got one box with one variable called mark 1, holding the number 72, one box with mark 2 holding the variable 40, etc. Okay? So just go and sit in the reserved seats for late people. Thanks. Anyone? So imagine we now have 10 students. Imagine I wanted to calculate the mark of all the students in this row here, all 10 of them. I could continue this. I could expand this process and I could go, right, let's define 10 variables. Mark 1, 72, mark 2, 40, mark 3, 50, mark 4, mark 5, etc., etc., etc. And then, if I want to calculate the average mark of all you 10 students, I could go mark 1 plus mark 2 plus mark 3 plus mark 4 plus mark 4, etc. And I can't even say it. It's getting that. And the risk of you making a mistake when you type out these type of expressions is huge. So this is like, it's starting to get a pain, and it's starting to get like not a good way to process data. Now, imagine I wanted to calculate the average mark of all students in this class, or if I wanted to calculate the average mark of all students in the university. This type of strategy of typing the numbers, like defining one variable for each number, is just not a good strategy, and it's going to take forever, right? So we need a better way to handle this type of situation. So, what we do is we use something called an array, okay? And what you can think of an array, you can think of an array as basically a variable that can hold a whole list of numbers. So it's got one name, so you can call it like student marks. So notice the S on the end, student marks, because it holds lots of student marks. And it can hold as many numbers as you want. So you can hold, what have I got, 5 numbers, or you can hold 50 numbers, or 1,000,000 numbers. And it's like a very handy way to store data if you're handling it on a computer. So this is called an array. So an array is a variable which can hold a whole list of numbers, and are super handy. And in MATLAB, you define an array like this. It's super easy. You go student marks, so in this case I've just called it student marks. You call it anything you want, like Bob or Fred or whatever. Open square brackets. Square brackets. Always remember this. Arrays have square brackets. It'll moan if you give it any other type of bracket. Then you just hammer in your list of numbers, so 72, 40, 50, 80, 60. Close your square brackets, and you've stored all of these numbers in this variable called student marks, okay? So now you can store as many numbers as you want in one variable. Any questions so far? It's pretty simple, okay? Yeah, go for it.
If you go back here, do we need to put the brackets enter?
Where? There?
No, if you go back.
Say stop. Oh, with the enter? No, that's just to show a put return. So that's just for you to. Right. So we can now define lots of different arrays to store data. So we can have an array of students, of ages. So age of student, 19, 20, 21, 19, 20, 21, 18. Stock market data, so you can hold the values of stock market data. So 5,000, 5,001. Temperature values, if you were taking temperature values over, say, a few days. Price of gold, time in seconds. We can store any list of numbers in this form, just by using, remember, these square brackets. Now then, once we've stored our data in arrays, we can start to do there's lots of mathematical operations we can get MATLAB to perform on the array of data. So for example, we can use the max command. So we can go max. So if we define an array called student marks equals 72, 40, 50, 80, 60, we can go max brackets, student marks, close brackets, and that will give us the maximum mark in the array, or the maximum number in the array. Min, student marks, mean, standard deviation, sum. So, we can now start to do some sort of useful things in MATLAB on arrays. Now, I'm just going to show you a little video of this. Can you see that at the back? Yeah? Good. So we define our array, marks, typing it in. Close the square brackets. We've now got our array marks in the workspace. I'm on the way, sorry. Max, min, mean, whatever. Super easy. So now we can perform these type of mathematical operations on huge sets of data. Good? Okay. Any questions so far? Right. Everything all right so far? Happy? Yeah? Okay, it's going to get more fun in a minute. Right, so, now then, in science and engineering, you very often need a list of numbers. So, for example, you might be measuring time every second. So you might be measuring something at 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. I can hear a murmur. Thanks. Thanks. It just makes my life more difficult to talk over you. Yeah, so very often you have to define a series of numbers, so from 0 to, 100 or something that's in a regular interval. Now, one way to do this would be to type in the array. So you might go time equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. But that's just a lot of work. And it was a lot of work for maybe 20 numbers. But it's going to be even more work if you've got 1,000,000 numbers. So MATLAB has got the command in it called Linspace. And what Linspace does is it defines a massive list of numbers with like a regular step between them. So we could define an array like this by going 0, 1, 2, 3, 4, 5, all the way up to 14. Or we could use the Linspace command, and we could go time in seconds equals Linspace, open round brackets, 0, which is the start value, 14, which is the stop value, and the slight trick is 15, which is the number of elements we want in our array. So if you actually notice, there's 15 numbers in this array, because obviously 0 is also a number. So it's 0 to 14, which is actually 15 numbers, okay? So that's the Linspace command. Now, you might think, oh, well, that's quite useful. I can now make lists of numbers. Pretty handy, but a little bit boring. It gets very useful very, very quickly. So what we can now do is the very powerful thing about MATLAB is it will perform mathematical operations on entire arrays. Okay. So if I said to the man in the stripy T-shirt there, could you please write down numbers from 0 to 100 and then take the sign of every one of those numbers? It would take you what? That's very embarrassing. Excuse me. Right. Yeah. So if I said, could you calculate the list? The sign of 100 numbers, it would take you a very long time. But in MATLAB, if you want to generate a list of numbers like that, then you just type sine x, and it will literally take the sign of all 100 of those numbers. So you can go Linspace, so 0, so you generate this big array, and you just go y equals sine x, and it calculates the sign of all those numbers. And then, this is a new command, the plot command, it'll plot it. So now we've got like a graphical calculator. So I'm going to show you this as a video now. Wah. Example 2. That's not helpful. Whoops. Right. Off we go. So we go x equals Linspace 0, 20, and 1,000. So this will generate a list of 1,000 numbers between 0 and 20. And now we take the sign of all of those numbers. Done. Really quick, right? Super efficient. Now we just plot it. Boom. Easy. So now you've got like a little graphical calculator, which is quite handy. Yeah, so it looks quite nice, doesn't it? Right, it gets better. It gets much better. Plop, 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 plop. Right. Now, all the mathematical functions you've learnt so far work on arrays. So sine, cos, arctan, tan, square root, everything works on arrays. Now, let's make this more exciting. Let's make some music with this, okay? Do you know how a loudspeaker works from physics at school? Yeah, shall I explain it to you again, just to, maybe some people don't. Basically, a loudspeaker has got a little voltage supplying it there, so some type of a voltage source. Then you've got an electromagnet here. And basically, when you apply power to that electromagnet, it energizes it. And so that here we've got basically a piece of paper. This is like a diaphragm. It's literally a piece of paper. And stuck on the piece of paper is another permanent magnet. So what happens is when you energize this electromagnet, it pushes this. Oh yeah, I'll just show it to you here. This is actually a loudspeaker. This is literally paper. So if you ever get your finger and tap a loudspeaker, you can just feel it's actually paper. And this little button in the middle is actually this little electromagnet. Now what happens is when you apply power in one way to the loudspeaker, it pushes this paper diaphragm out like that, yeah? And it generates a compression wave. So it actually pushes air out the way. And then when you apply, so that's a positive voltage. When you apply a negative voltage, it pulls the diaphragm back in and sucks air in towards it. And you get sort of a wave traveling the opposite way. Okay, so we now push air about with our loudspeaker. Now if we apply 50 hertz, this is the key, sine wave, to our loudspeaker, we can push air away, pull it back, push it away, pull it back. And that's basically how a loudspeaker generates music. So if we apply 50 hertz here, this will go in and out 50 times a second, and you'll get, basically, you'll hear 50 hertz. So you'll hear like a low bzzz, like you hear from electric lights. So we've made a sine wave with MATLAB, okay? We just saw that. If we could somehow magically send this sine wave to the audio card or the audio chipset in the computer, we could maybe move the speakers of the computer. So this is how we do it. So firstly, let's make a sine wave. So this time, rather than having an array of 200, I'm going to have a much bigger array. So it's going to go from 0 to the number 10,000, and we're going to have 10,001 elements. And you might say that's a bit of a weird number, but I've chosen these numbers to basically make it audible to the human ear. Then we're going to take the sine of this array, and then we're going to plot it. And we'll get something that looks a bit like that. And then, to send it to the sound card of the computer, we just use the sound command. And what the sound command does is it sends this sine wave that we've generated here to the sound card of the computer. And this, you might say, well, what's this 1,000 here? What this is saying to the computer is please send 1,000 elements of the array, so 1,000 bits of data per second to the sound card. So we're saying how fast the array gets shoved to the sound card, okay? So if you ever looked on a CD and it says sample rate 44,100 times a second, that means your CD is spitting out like 44.1 kilobytes of data to the loudspeakers every second. So let's have a look at this. Let's watch this in action. Where is it? Boom. Oh, you know what I need? I need an audio cable. Hang on. What's that? There we go. Right, off it goes. So firstly we make our array. Linspace, 10,000, 10,001. Loads of data. Take the sine of it. Get a sine wave. Let's have a look at it. Plot it. Now this looks like just blue, but that's because I've had to make so many sine waves just so it's like long enough for your ear to hear it. So let's zoom in. So this is looking a bit like a sine wave, yeah? It looks enough like a sine wave to believe it's a sine wave. Now let's send this to loudspeakers. That's no good. What's going on here? I'm sorry, this needs audio to work. I'll tell you what, I'll put my mic on it. It's just like a monotone. Okay, it could be like, you know, a ship's horn or something. Okay. Right. It gets better. Right. Now then, I don't know, what we could do now is we could like make the computer play Happy Birthday with like different sine waves or something, but that'd be super boring. Have you ever seen the Formula 1 sports cars with the engines that can go so fast you can actually play Happy Birthday on the engine by revving it? The same type of thing. So, but let's not do that because that's dull. Let's do something much more fun. Let's actually play some real music. Now, for this, I have to teach you another command called the load command. And what I've done is I've made a file called mydata.dat. And in this file, I have stored a list of numbers. So literally, I've just typed those in. So 10, 20.1, 10.4, 50.5, 50.6, 80.8, 80.9. So I've just literally typed those in. There's nothing special about that file. Then in MATLAB, if you go y equals load mydata.dat, it will load this file into an array. So you've now got a way to like suck in numbers from a file, right? So this is getting super useful. Now then, so yeah, we just load this file into the array. And what we can do is we can now, if we store audio data in this file, so if you imagine +1, so +1 represents a positive voltage when it pushes the speaker out, and -1 represents a number where it pulls the speaker in. What we can do, let's move this up, what we can do is we can basically, we've got here values in a file between -1 and +1, and this is actually real audio data. So this is exactly how audio data is actually stored. Now then, let's zoom in on this audio data, have a look at it. How many data points are in this array? What's that in like English words? 12 million. That's a load of data points, right? Now, do you think it's music or do you think it's speech? Why do you think it's speech? Sorry? 5 seconds. Good. You're thinking right. I'll tell you what, it's actually music. And I'll tell you how you can figure this out. If you listen to my voice, I have to take breath. I've got to pause, right? I've got to go speak, yeah? There's no, like, gaps in that. And that's because somebody's, like, strumming away on a guitar. The other key to this being music is, can you see there's, like, a regular pulse? Boom, 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 boom. It's like regular beat of music, okay? Now then, this is CD quality music. This is 44,100 piece of data per second being shoved to the sound card. This song only lasts 272 seconds, but yet we've got 12 million pieces of data. Now, this is a super common problem in engineering. Your data sets very quickly. So we've only recorded seconds of audio data. We've got millions of bytes to deal with. This problem will bite you whenever you start to do like analyzing engines or whatever. You've got to record lots of data. You can very quickly get loads of data. And how are we doing for time? Oh, we've got ages. I can slow down. What was I going to say? Yeah. Have you ever tried to open a big spreadsheet in Microsoft Excel? You know, as soon as you get past maybe a few thousand numbers, the thing's just super slow and it's useless. Any of these desktop products are basically useless when you start to handle lots of data. And especially if you put 12 million numbers into it, it's just going to die. So this is where you just have to leave all these fancy PowerPoint, whatever Excel tools behind, and you've just got to jump into MATLAB to solve your problems because other tools just can't hack it. Right. So now let's play an example. Now I'm going to try and get the just give me a second, see if I can get the audio going. Volume. Don't know. I'm just going to hold my microphone next to it. I apologise for the rather poor. Right. Right, okay. So I'm just going to hold my mic next to it. It's a rather tiny. Okay. So we load the data file. Now this is a massive file, so it actually takes a few seconds to execute. So you can see it's like the computer's actually pulling a load of data from hard disk. That's all the music data. Loads of it, right? Now let's just have a look at it. Let's plot the music. So this is the audio data. Now let's zoom in. Now I think we're actually zooming in on a guitar. Okay. Very good. Now let's send it to the speakers. Now that's the array. So that's the nut bolt. Now, this is part of the coursework, okay? Now, this is a tip. It gets super irritating. I think the coursework, you've got to, like, process boat horn sounds or something like that. It gets super irritating after a while. And when you want to stop the music, or stop whatever irritating sound you're listening to, you type clear sound, and that just shuts it off, okay? So that's a useful command for later. Right, let's crack. Oh. So before the end of this lecture, we're actually going to remix this song, but with MATLAB. So, good. Next. Now then, extracting data from arrays. So this is another very important topic. So we're now going to basically look at array manipulation, okay? So we've looked at like using arrays and stuff like that. Now we're going to look at basically chopping bits out of arrays and putting stuff in. So very often in engineering, you're going to have a huge data set, like talking about terabytes of data, and you might only be interested in 0.01% of it. So imagine you're an engineer in somewhere, I don't know, like Iran, where they get lots of earthquakes, and you set up your computer to record audio data, basically, which is effectively what an earthquake sort of is, to wait to process what the earthquake sounds like, effectively. Now, earthquakes don't happen every day, so what's going to happen is you're going to run your computer for maybe a year, and it might record no earthquake. And then you might run it for the next year, and there might be 5 seconds of earthquake in that year. So out of 2 years of data, recording 24 hours a day, you've got 5 seconds of data you're interested in. So very often, you've got to pull little bits of data out of a huge data set. So let's kick off with a super trivial example, then we'll very quickly build up the usefulness. So imagine we've got marks of these 10 students in the front row. And they are very good students. They get 70, 80, 90, 100, 50, 40. We can store this data in an array with these square brackets. Now, this is very important, what I'm going to say now. Arrays are indexed. So every element in an array has got an index. So the first element here has got the index 1. The second element has got the index 2. The third element has got the index 3. The fourth element has got the index 4. 50 has got the index 5. Sixth element has got the index 6. So arrays are like numbered, starting from 1 to the number of elements in the array. They always start at 1. In MATLAB, they start at 1. Other languages, they start at other numbers, but in MATLAB, it's 1. Now, if we want to extract the marks for only the students, basically elements 4, 5, and 6, all we do is we define a new array Z, and we go marks, so that's the name of this array, open round brackets. You just got to remember it's round brackets. The position of the first element we want to extract, in which this case it's 4. The position of the last element we want to extract, in which case it's 6. And then we hit return. MATLAB's going to pop out the data between 4 and 6, which is 4 and 6, and print this out here. So this is basically how you pull data out of an array. I'm going to do another example. I'm going to ask you if you've got any questions for it, if you're confused at all. So imagine we have some temperature data. Here we've recorded temperature every day. So you go temperature equals 30, 29, 28, 29, 27, 10 lots of data. And we want to pull out the first 5 days worth of data. So all we have to do is go first half, so that's just the name of the variable name. Temperature, that's the name of this original array. And we want to pull out elements from 1 to 5. So we just go 1, dot, dot, 5, close round brackets, and it's pulled out this data here between elements 1 and 5 and put it here in a new array. Any questions so far? Anybody really confused? Are we happy? Super. Okay. And I don't mind if you stop me also in the lecture and say, I don't understand that bit. Really happy to make it interactive like that. So, back to our music example. Imagine, we've got this array with 12 million elements, and imagine we just want to pull out the guitar. We just want to hear the guitar in the beginning, just see what it sounds like. We know our array's got 12 million elements, but we can pull out now from our array the music between the 1.15 millionth element and the 1.2 millionth element. And that happens to be the guitar. I know that because I looked at it. And when we pull this out, we get this pattern of music. So to do this, to do this whole procedure of just listening to the guitar, what we do is we go y equals load MATLAB music file.dat. So that loads the music file into y. We go new data equals y is the name of the array where our music's stored. 1.15 millionth element, 1.2 millionth element. We can plot the data like that, and then we can send it to the sound card at a rate of 44,100 samples per second because it's CD quality music. And then, yeah, we can listen to guitar, just the guitar. So let's do that. I've got to take my mic off again. Right, so we loaded the music. It takes a while because it's quite big again. And you'll find this also with your coursework. It will take a little bit of time to load the sound file. Still loading. There we go. All the music data. Now we'll define a new array called cut data. And we'll go from 1.15 million elements to 1.2 million elements. Cut that data out. We go sound, cut data, then speed, and now, if we adjust these numbers, we can go about on the track. This is different bits of the track. So I think we're going to listen a little bit more of the sound now. So we go a bit further, now we get her voice. Bit further more. This will be the last one we do. I think we go backwards. Oh no, we're going to listen to more of the voice. We can now manipulate huge arrays containing huge amounts of data with absolute ease. Right, so how long we got? We got about 5 minutes, perfect. So now we're going to do some remixing of the song using MATLAB, okay? So, very often in engineering, you might have 3 sets of data. So you might have, for example, so this is another silly example, just to get you thinking about, get you into the more complicated problem. So imagine there's, how many are in there? 7 students, and you all get marks in physics, maths, and chemistry. And you define 3 arrays of marks of physics, chemistry, and maths. There we are, in box form. Marks in physics, marks in maths, marks in chemistry. Now, I say, can you calculate the average grade of those students? You could do it like this. You could go, define the array, marks in physics, marks in maths, marks in chemistry. Then you could use the average command, AVG, and you could go, so open brackets, average marks in physics, average marks in maths, average marks in chemistry, divided by 3. Okay, that'll get your answer. That'll be perfectly acceptable in an exam. But there's a more elegant way of doing it that's more useful. And another way of doing it would be to just join those arrays all together, just like stick them all together to start with. So in this picture here, I've got, here's the array marks in physics, here's the array marks in maths, and here's the array marks in chemistry. We can just literally glue them together And then we can just do one average operation on the whole array. So if we go total marks equal, so we define our arrays here, boom, boom, boom. We go total marks equals, open round brackets, then just the name of the array that we want to start the big array off with, then the name of the next array we want to join on the end, and then the name of the next array we want to bolt on the end. And the result is we get all these three arrays just bolted together. So I've color-coded it. So you've got marks in physics here, marks in physics, marks in maths, marks in maths, marks in chemistry here, marks in chemistry. So we've literally just got one array, bolted on another one to it, bolted on another one. It's called building arrays. It's super handy for lots of situations. Now then, let's do some remixing of the song, because now we can chop out elements from the song. We can then bolt them together. So we've got the ability to mix up this song with MATLAB. So let's firstly load in the music file. So load music file.dat. Sorry? What? No, it's 5.2. Bye-bye. So, where was I? Completely lost my train of thought. Right, okay. So what we're going to do is we're going to go y equals load MATLAB music file.dat. So we're going to load this whole music file in. We're going to cut out just the guitar here. So we're going to go new data equals y. So this, 1.15 millionth element to the 1.2 millionth element. We're then going to make a remix of the song with just the guitar. Okay, so we're going to bolt the guitar, 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 guitar. So we should hang bing, 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 bing of the guitar. So we're going to do this by going remix. So this is the name of the variable that contains our remixed data equals open round brackets new data. So this is just the guitar. New data, new data, new data, new data. So this will play the guitar 1, 2, 3, 4, 5 times. And then we just spit it out to speaker. And we should just hear the guitar repeated again and again and again. So let's have a go at that. Whoop. I've got to put my mic on the speaker, sorry. So we load the data in, as before. We cut the guitar out. There we go, there's the guitar. Let's just play this. After the song. Now let's make a new array containing multiple copies of that guitar data. Cut, cut, cut. Whoop, let's just do 2. Play that, and we've got to change cut to remix, because that's the array containing both sets of data. Remix, remix. And now we can put as many as we want, 4. Yeah, and we can do as much as we want. It gets a bit repetitive. We'll do one more time, and then I think we'll call it a day. I want to show you one more thing. Yeah, I've got another 3 minutes of your time. Right. So we've now done complex numbers and processing big data sets. The last thing you don't know how to do before you can really get started with your coursework in earnest is making MATLAB programs. Okay, so saving MATLAB programs basically. At the moment you can just type commands into the command window. What you can't do is store those commands to be used later. If you turn right to the back of the lecture notes, yeah, I've made some, basically, it's like a click-through guide on how to basically save all those commands into a little program file that you can run again and again and again. And I'll go through this in the class, but it's there if you want to have a go on your own in the examples class. So, the other thing, last thing, is I've popped onto here today's worksheet. So this should entertain you for at least, if you do it all, probably 2 hours this time. So there's a lot more meat to it than last lab. So yeah, off you go to C19, C20, or top floor of ESLC. I'll see you there in a few minutes.